My dear friends, welcome back to the electronics world. This is lecture number 7. In lecture number 6, we studied about how Niels Bohr modified the theory given by Ernest Rutherford and published his postulates, which is nothing but the concept of modern atomic theory. We also learned about one question that could not be answered by Ernest Rutherford, that when the electrons are revolving around the nucleus, they should radiate energy, and by radiating the energy they should ultimately lose energy and fall into the nucleus, but that never happens. So the answer to this question could not be provided by Ernest Rutherford, rather it was provided by Niels Bohr. We saw what atom consists of: the three subatomic particles, electrons, protons and neutrons. We studied about atomic number, valence electron, valence shell. Okay, so in this lecture we are going to study about energy band theory and classification of solid. So let's come and study about energy band theory. For studying about energy band theory, we must know about energy level, the concept of energy level. Okay, so let's come and study about first energy level, then we will come to energy band theory. In the last lecture, we had already studied that the electron which is revolving around the nucleus in certain path possesses some amount of energy. Okay, so the energy possessed by the electron is the summation of some of the kinetic energy and potential energy. That means the electron has kinetic energy as well as potential energy. So the kinetic energy is due to the movement of electron, and the potential energy is due to the force of attraction between the electron and nucleus, because the force of attraction between the electron and nucleus. So kinetic energy and potential energy. So this is the net energy that is possessed by the electron which is revolving in particular cell. Okay, so let us say that this is our nucleus. Let us assume that this is an atom, and let us assume that these are the cells. So this is our first cell. Yes, we are studying about energy level. Energy possessed by the electron is equals to the sum total of its potential energy, kinetic energy and potential energy. Okay, so this is our first cell, which is at a radius of, rather I can say R1 from the nucleus. So this is our second cell. So this is at a radius of R2 from the nucleus. So let us denote this nucleus properly. Okay, this is our nucleus. So this is our third cell. So this third cell is at a distance of R3 from the nucleus, and similarly the fourth cell is at a distance of R4 from the nucleus. Let us assume these are the electrons revolving in the first cell. These are the electrons which are revolving in the second cell. These are the electrons which are revolving in the third cell. Let us say these are the electrons which are revolving in the fourth cell. So let us come back to our theory. Our theory says that the energy possessed by the electron is sum total of kinetic energy and potential energy. That means whatever this, let us consider this electron, which is these two electrons which are revolving in the first cell. So these two electrons possess the energy which is nothing but the kinetic energy and potential energy. Okay, so what is this energy again? This energy is nothing but the energy of that cell. So that means whatever may be the number of electrons moving in this cell, they should have the same amount of energy. Okay. So similarly, if you come to the second cell, so these are the electrons which, that are revolving around the nucleus, and in the second cell. So similarly, all the electrons which are revolving around the nucleus in the second cell, they also have some amount of energy, which is different from the energy possessed by the electrons which are revolving in the first orbit or first cell. Okay. Again, this energy possessed by the electrons is equal to the kinetic energy and potential energy. Summation of kinetic energy and potential energy. Okay. So let's come to the third cell. Again, the same concept. These are the electrons revolving around the nucleus, and they are at a distance of R3. This first cell was at the distance of R1, second cell was at the distance of R2, third one is at the distance of R3. Okay, so all these electrons are moving in the third cell, and they also have some amount of energy associated with them. Okay, so this is nothing but the energy possessed by the electron, which is equal to kinetic energy and potential energy. Okay, and this is nothing but the energy of the third cell. So that means all the electrons which are moving in this third cell must possess the same amount of energy, which is fixed for that cell, which is fixed for this third cell, and same is true for our fourth cell. So that means we could see that the electrons are moving in the first cell, they have some amount of energy. The electrons which are moving in the second cell, they also have some amount of energy which is different from the first cell. That means the electrons energy possessed by the electrons which are moving in the first cell. Again, if we come to the third cell, all the electrons which are moving in the third cell, they also have same amount of energy, which is different from the second and first cell. The electrons moving in the second cell and first cell, the energy possessed by the electrons moving in the second cell and first cell. Okay, so here exactly what happens, that means if we go higher in the order from the nucleus, so rather I can say if I will go further from the nucleus, the energy possessed by the electrons increases. Okay, so here I can show you. The energy possessed by the electrons which are moving in the first cell, it is least amount of energy. So let us say this is our this is at the distance of r1. So at r1 I know that we know that the first cell, the radius of r1 is nothing but the radius of the first cell. So this is our first energy level. First energy level. That means the energy possessed by the electrons which are revolving in the first cell is known as first energy level. Similarly, if we will go to distance of r2, here you can see this is our second energy level. That means the energy possessed by the electrons moving in the second cell is known as second energy level. Similarly, if we will go to distance of r3, this is our third energy level. And for R4 we will get fourth energy level. So from here what we saw? We saw that as we go higher in the order from the nucleus to further distance, then our energy associated with the electrons also increases. So here you can see it is our nucleus and we are moving at the we move to the distance of r1. So this is our first energy first cell, and the electrons, the energy possessed by the electrons which are revolving in the first cell is known as first energy level, and this first energy level is least in amount. Okay, so if we go little bit higher, so r2, so as with the distance of the cell increases, or you can say if the radius of the cell increases, so you can see that the energy associated with the cell also increases. That means the energy possessed by the electrons revolving in that particular cell also increases. So here it is at a distance of r2, and here we know that r2 is greater than r1. R2 is greater than r1. So that means the energy possessed by the electrons which are revolving at a distance of r2 from the nucleus, that is in our second cell, the energy possessed by those electrons is known as second energy level. So that means the second energy level has a value which is more than the value that is possessed by the first energy level. So similarly, if we go to r3 distance, so that is our third cell, the electrons which are moving in the third cell, they also have some amount of energy which is more than that of the second cell. So here that is why we are getting this third energy level over here. So that means because that is R3 is greater than R2, that means that is why our third energy level is more than second energy level. Okay, so similarly for R4, we can see that because R4 is greater than R3, that is why the fourth energy level has some value which is greater than, that is our third energy level. So this is the concept of our energy level. So energy level is the energy possessed by single atom, isolated atom. Okay, so let us study what energy band is. Let us consider any solid. Okay, so this is a solid which consists of a number of closely packed atoms. So all these atoms are quite closely packed, as you can see over here. Okay, so let us assume any two neighboring atoms. So let me say this is my atom A, this is my atom B. So atom A has its own first energy level. Atom A has its own first energy level. Similarly, atom B also has its own first energy level. Because you can see that atom A is quite close to atom B, that means the first energy level of atom A interferes with the first energy level of atom B because they are quite close. Okay, so similarly you can see other atoms are quite closely packed. That means for the first energy level of all other atoms also interfere with the first energy level of these two atoms. So similarly you can see atom A has its own second energy level. Atom B also has its own second energy level. So here also, because these two atoms are quite close, the second energy level of atom B will interfere with the second energy level of atom A. So similarly, because all other atoms are quite closely packed, so all the second energy level of all other atoms, they will interfere with these two second energy levels. Similarly, we can see that for third energy level, the atom A has its own third energy level, atom B also has its own third energy level, all other atoms which are quite closely packed, they also have their own third energy level. So here all these atoms, all the third energy levels will be intermixed. So you can say that so in this process what exactly happens, a range of energies come into picture. So because atoms are quite closely packed, so that the energy level of one atom interferes or mixes with the energy level of other atoms. So that gives rise to the concept of energy band. The range of energies, you can write down the range of energies possessed by the electron in a solid is known as energy band. So if we will present it in a graphical manner, we can see that. So suppose that this is our edge of nucleus, and from this edge, so this is at a distance of r1. So this is our first energy level, r2, second energy level, r3, third energy level, so this is our r4, fourth energy level. This is for our energy level. And for energy band, so this is our first energy band, second energy band, third energy band, and our fourth energy band. Okay, so here we can see so this is our energy band. The simplest differentiation between energy level and energy band is that energy level points to a single value of energy, whereas the energy band points to a range of values. So here you are having a single value, but here you are having a range of values, multiple values are there, because that is why it is a band, and because it is a single value, that is why it is only a level. Okay, so here using this concept, let us classify our solid. Okay, so what's classification of solid? What is a solid? Something which has a definite shape and size and weight. Okay, anyways, so solids are also of different types. They have different ways to be classified, but we will be taking our conductivity to classify the solid. Okay, so considering the conductivity of the solids can be classified into three types: conductor, insulator, semiconductor. conductor, insulator and semiconductor. So what conductors are? Conductor is that type of solid which allows current to pass through it. Allows current to pass through it. What insulator is? Insulator is that type of solid which does not allow current through it. And semiconductor possesses the characteristics of both conductor and insulator. So we can say it's a middleman. Okay. So it allows current to pass through it, but the amount of current is less than that of the conductor, but more than that of the insulator. So if we will classify conductor solid by virtue of its conductivity, then conductor, semiconductor, current is highest in conductor, least in insulator. So insulator, it does not allow current to pass through it. That does not mean that no current can pass through it. It is not the exact meaning, but the current, there may be some current which is very negligible. It's altogether negligibly very small. So that is why we can ignore it. So this is least, this is highest, and this is in between. This is in between. So current available here in semiconductor is less than that of the conductor, but more than that of the insulator. We can classify these solids by using the concept of resistivity as well. So resistivity is one property of resistance, and if you are considering the resistivity, here you can say that insulator has high resistivity, because if the resistivity is high, then the current will be definitely least. Okay, here it is having conductor least resistivity, because the resistivity is least, the current will be of highest order. And for semiconductor, the resistivity will lie in between this least resistivity and high resistivity. That means the semiconductor has the resistivity which is higher than that of the conductor, but lesser than that of the insulator. Okay, so let us come and describe these three types of solids by using the energy band theory. Okay, so let us come and study about energy band description of solid. Dear friends, till now we have studied about classification of solid by taking conductivity, and also we have studied about the energy band concepts. Okay, so now let us classify the solids by taking the energy band theory. For studying about the energy band description of solid, we must know about three terms: valence band, conduction band, and forbidden energy gap. What valence band is? So valence band is nothing but it can be thought of as the summation of valence electron plus energy band. Valence electron and energy band. We know that the outermost shell of an atom is known as valence shell, and the electrons which are present in the valence shell are known as valence electrons. We also know that energy band is nothing but the range of energies possessed by the electrons. So then what is our valence band? Then valence band is the range of energies possessed by the electrons present in the valence shell, or else we can say that the range of energies possessed by the valence electrons is known as valence band. Okay, so similarly another thing, conduction band. So what is conduction band? So conduction band is nothing but it deals with the term conduction exactly deals with the electrons which are responsible for carrying current. So what is our conduction band? Conduction band is the range of energies possessed by the electrons which are responsible for carrying current. So then another concept, forbidden energy gap. The forbidden energy gap, it is the gap between the or the distance between the valence band and conduction band. Distance between correct? Okay. So let us use these three terms and study about energy band description of solid. Okay. So the first classification is nothing but our conductor. So what is a conductor? It's that type of solid through which current can pass. So that means, so in other words, we can say that it must have some of the electrons which are responsible for carrying current. That means the conductor has that type of electrons, and that's too in abundant amount, which are responsible for carrying current. Okay, so let us use that principle here. So here we can see that the conduction band overlaps with valence band. So, but in case of conductor, we know that it has that type of electrons, and that too in abundant amount, which are responsible for carrying current. So that means our conduction band should be completely filled. It should be filled so that the electrons can be, much of the electrons, abundant amount of electrons can be available for carrying current. So how is it happening over here? We can see that, so because due to this overlapping, there are some electrons present in the valence band which are also present in the conduction band. So let me say, if an electron is present somewhere here, so this is actually present in the valence band, and also it is present in the conduction band. So all these electrons, they are part of the conduction band as well, even if they are present in the valence band. Okay, so let us consider about another electron somewhere here outside of this region. So this electron, if we will apply a small amount of potential difference to this electron, I mean to say to the valence band, so the electrons which are present over here like that, they can easily be made to go to the conduction band, because this distance is very less. The distance is very less, and due to that reason, we can see these electrons which are present over here, they can easily go to the conduction band. So in this way, the conduction band can have much electron, and these electrons can carry current. They can help the current to flow through that solid which is conductor. Okay, here what you can see, we are not able to see the forbidden energy gap. It's not present. So in our conductor, conduction band is completely filled. Okay, so let's come and study about insulator. In insulator, what happens? So this is insulator. So here it is our valence band, this is our conduction band, and this is our forbidden energy gap. This forbidden energy gap is up to the order of 15 electron volt, and this 15 electron volt is very high a number. So that means the electrons which are present over here, initially please remember that initially the electrons are present in the valence band, and so what we are doing, so we are trying to send these valence electrons to the conduction band, but here because of this distance is very high, our forbidden energy gap is very high. That means the electrons which are present over here, they cannot go to the conduction band. So that is why you can see that conduction band is completely empty and valence band is completely filled. So that because this is completely empty, so there is no electron present here in the conduction band to carry current. So that is why the insulators do not carry current. But one thing, my dear friends, if the temperature of the insulator is increased, so what happens? These electrons exactly get sufficient energy, so that some of the electrons can come to this conduction band. If the temperature of the insulator is increased, so these electrons can come to here. So insulators also start conducting to some extent, because some of the electrons will be available over here. So that is why insulators have negative temperature coefficient of resistance. They have negative So let's study about semiconductor. What is semiconductor? Semiconductor is that type of solid whose conductivity lies in between conductor and insulator. That means the conductivity is lesser than that of the conductor but more than that of the insulator. Let's study this theory with respect to the energy band. Okay. We know that a solid can conduct only when the conduction band is filled. Here we can see that the conduction band is not completely filled, it is also not completely empty, but it is more or less empty. So that is why its conductivity is very less, and valence band is completely filled. So this is what happens at room temperature. If we decrease the room temperature, so we will not see any electron. We will hardly see any electron in the conduction band. So the conduction band becomes very empty, and the valence band becomes completely filled. That is why in that condition the semiconductor behaves like an insulator. And if we increase the room temperature, so what will happen? So some of the valence electrons will get additional energy and they will simply cross over to the conduction band. So in this way we can see substantial amount of electrons present in the conduction band. So it behaves like a conductor. So my dear friends, semiconductor at room temperature, it has its valence band is almost filled, it is completely filled, and the conduction band is almost empty. With this we have come to the end of lecture number 7. If you have any doubts, if you have any queries, if you want to give any suggestions, you can just write to me in the comments box. Thank you.